Well, it's going to get fun now. This one, they give us, for example, 3, they give us the axis of symmetry and they give us 2 points. They don't give us anything else. So we don't know the vertex, we don't know what A is, we just know that the x-coordinate of the vertex, being the axis of symmetry, is -1. So we can work with what we know and see where we can get from there. So we know that y equals a times x minus p squared plus q. And we know that we can take this -1 and put it in here. X minus -1 is just x plus 1. So that's our starting formula. We also know that I could plug those coordinates into y and x. The only problem is I still don't know a and I still don't know q, so there's 2 things I don't know. When there's 2 variables that you don't know, substitution is helpful. So the first thing we're going to do is all that we can, and that is plug in those values for each of the given situations. So for a, I'm going to make y, 3 equals a times 0 plus 1 squared plus q. So I've done what I can. Now I'll just simplify. 0 plus 1 is 1, squared is just 1. So when I simplify what I can, I end up with a plus q, because this whole thing just became 1, and 1 times, I could write 1a times q if you want, it's the same thing. So that's all I can do there for now. I'll go over to b. Same thing, I'm going to plug in my y. 9 equals a times my x plus 1 squared plus q. 9 equals -3 plus 1 is just going to be -2. Squared is 4, so it's just going to be 4a plus q. So now I have a formula where I have 3 equals a plus q and 9 equals 4a plus q. I have to be able to combine them somehow. We're so close. So I'm going to look at the simplest formula, and I'm going to rearrange this formula to be equal to one of those. And I think I'm going to pick, doesn't matter which one you pick, but I think I'm going to pick q because q is by itself over there. So I could just plunk it in. And this is a really simple formula.